This problem here illustrates something useful. When you first look at this, you might think that you should use quotient rule because it's certainly a quotient. And you could do that, but really there's a useful trick that makes it much quicker by using the chain rule. But let's do it both ways. Let's first do the quotient rule. This is the longer way to do it, but we can still arrive at the right answer, no problem. So how is the quotient rule going to come into play here? Well, the derivative of the top is 0 times the bottom left alone minus the top left alone times the derivative of the bottom. And this is going to be chain rule here, right? Do the derivative of this is chain rule. Notice how we have a chain rule inside of a quotient rule. Very often we have to combine our rules of derivatives, and it won't just be one rule, it'll be several rules altogether. So how do we find the derivative of this using the chain rule? Well, it's pretty easy. The 5 comes to the front. We're ignoring the 2x to the 4 minus 3. It becomes a power of 4. And then we multiply by the derivative of what we were ignoring. Let's fill that in. And then the bottom is the square of what it was before. When I square a power of 5, 5 times 2 is 10. So that's what we have. Now, what happens now? Well, notice this 0. It actually destroys all of this, doesn't it? So that's all gone. Minus 1 times 5 is just minus 5. This part I'll just recopy. And right here, well, this is easy. This is 2 times 4 is 8, x to the power of 3 minus 0, all over this to the power of 10. And we're pretty much there. The top can be simplified just a little bit. Negative 5 times 8 is negative 40, x cubed. And notice that we have 2x to the 4 minus 3 in the top and the bottom. And here's to the power of 4, here's to the power of 10. So we can actually simplify that a little bit. We could subtract those exponents. Why don't I think about, usually we do 4 minus 10, we get negative 6 on the top, but it's just the same as if I bring this to the bottom, it becomes negative 4. 10 minus 4 is 6. So we get 40x cubed over 2x to the 4 minus 3 to the power of 6. And there's our final answer. Now, that's perfectly fine to do it this way. We use the quotient rule. But I want to do it another way, which I think is better. Whenever you have a constant up here, if there's an x in the numerator, what I'm about to say over here is not going to work. But if it's just a constant, like 1 or any number, then we have a little trick available to us that makes it easier. Let's rewrite this first. Let's bring this to the top and make it to the power of negative 5. And now we can actually do the derivative right now with the chain rule directly without even bothering with the quotient rule. Let's see what happens. The minus 5 is going to come to the front. This is going to be ignored. Minus 5 minus 1 is minus 6. And then we multiply by the derivative of this. Since I don't have a lot of room, I'm just going to do the derivative right away. It's 8x cubed, right? And we're basically done. Why don't we minus 5, like this 2x to the 4 minus 3 to the minus 6, that's going to come to the bottom. Let's do that right now. And for the top, we just multiply negative 5 times 8x cubed, and we get minus 40x cubed. Minus 5 times 8 is minus 40, and then the x cubed is trailing along. And we have the same answers over here, and this was much quicker, wasn't it? So I like doing this trick. If there's ever a constant up here, why bother with the quotient rule? Because you know the derivative of the constant is 0, and it's going to just make all of that first term go away anyways. So I think that's a useful thing to remember. So that's how you do this one.